One method to solve a system of equation is basically to use the graphing method, and it's not too difficult. Here's the basics. You're going to run into one of three different scenarios every single time. Here we've got the blue y-axis and the blue x-axis. I'm just wanting to make sure you understand that's our y and x-axis. And then we've got the two equations graphed. Two equations normally would show two different lines. So here's one going down to the right, one going up to the right, and they intersect. This intersection is the exact point of solution. You would take the ordered pair from this dot, that's your x and y value, and that shows that there would be one solution. So if the lines bump into each other once, it's one solution. Now over here on the far right side is what happens when the lines are parallel and they never do bump into each other. As a result, you would say, hey, there's no solution to this system of equations. And then you also have this situation, and it does happen occasionally. Basically, it's where the equation is the exact same thing. It's repeating itself. So when you go to graph the second line, it winds up going exactly where the first one is, and it's directly on top of it. So as a result, you don't even see two different lines. You just see one, but that would mean that, hey, this would be a solution, this is a solution, that's a solution, that's a solution. Basically any point on that line would become a solution, so we would say that is infinite solutions. So these are the three basic situations that you'll run into when you graph a system of equations, and if you can find where it's one solution, you'll just write down that ordered pair as the solution point. Let's go through and actually show you how it works in action though. I think I've got two different examples set up for you. Yeah, so there's the second one we'll get to, and here's the first. Now, just to let you know, not always the equations are not always going to be put in slope-intercept form. At times they could be standard setup. They could also be in point slope. It could just be a mess, and you'd have to rearrange and isolate that y all by itself. But if you can get it into slope-intercept, this becomes a very easy way to find the solution to a system of equations. So my y-intercept for this one is positive 3. I want to put a red dot right over here by this equation. And then my slope is up 1 and to the right 2. Up 1 and to the right 2. And that also means that I could kind of backtrack my way over here. And you want to get as many points as possible on here because you don't know where the second line is going to intersect. So let's go through and connect the dots now. It's not perfect, but it'll give us a basic idea of where it's at. And now let's use this blue pen to graph our second equation. Our y-intercept is at positive 1, so I'll put a dot there. And now I would go up 3 and to the right 2. 1, 2, 3, and then over to the right 2. 1, 2. And as you can see, we're going to hit that point right there. And so I know that the solution to both of these is this point right here. Let me get a highlighter. This is going to be our solution point. So it's 2, 4. Our solution is 2, 4. And just to prove that it's going to solve both of these equations, because that's what a solution does, it makes both of the equations come true, let's plug this into the equations and see if it's correct. 4 is the y value, so that's where that's going. And then 1/2 times x, x is 2. And then it says plus 3. Well, 1/2 times 2 is 1, and 1 plus 3 is 4. So that one's true. And now let's plug this one in. 4 equals 3/2 times 2 plus 1. Well, 3/2 times 2 is, let's see, 6/2 or 3. So this equals 3, and 3 plus 1 is 4. So it made both of the equations true. So I know for sure that this graphing method, where the lines intersected, does give me the true solution to both of the equations. Let's go through and do this one. Let's see, my y-intercept is negative 2, and that's a positive 1, so that'd be up 1 and to the right 1. And that pattern holds true. And again, I'm extending this line out as far as I can because I don't know where the second line is going to go. Let's go ahead and connect those dots before we forget. There we go. And let's use the blue again for the second equation. So let's see, it's at a positive 2, and I would go up 1 and to the right, up 1 and to the right. And then suddenly what I realize is I'm doing that is we've got parallel lines. Um, should have realized it as I was looking at the equations, because see right here, it's got the same slope, but I have different y-intercepts. That means that these two lines will never touch, so there is no solution. And once you do enough of this graphing, pretty soon you can actually start to save yourself quite a bit of time. As soon as you go, same slope, then just quickly check to look at the y-intercepts. If they're different, they're never going to touch. If they're exactly the same, well then you'd be graphing the same line and it would be infinite solutions. That's all it takes though to use this graphing method is you go ahead and graph both of the equations, and if they touch, you know where the solution is. If they never touch, there is no solution. And it's pretty straightforward.